Good morning, everyone. How are you doing? Oh, it's still good morning. I don't look at the watch. It's still good morning. Still 4 minutes left. So yesterday, a whole bunch of us went down to this place called Casa Patas, and we saw some amazing flamenco dancing and music. So if I lose internet connectivity, I'll try and entertain you using what I learned last night. So I hope the internet stays. So far, it seems to. Hola. All right, folks, good afternoon. My name is Vijay Tiwari. I run the program management team for Virtual Machine Manager and System Center. It's truly a privilege to be here and talk to you about VMM. We have a bunch of folks from the product team, from our team here as well. We got Chung and we got Eric here. So it's fun to be here and talk to all of you. So this crowd is not too big. So if you have any questions, just feel free to ask me as we go along. And we'll take questions as we go. And if it becomes too much, then I'll request you to hold it till the end. All right. So before I go any further, we'd like to thank you from our perspective. This is actually the VMM team. This picture, it's not the entire team, it's almost the entire team. We're about slightly over 100 people in the team. This picture was taken before MMS. It was taken in the month of April, which is kind of really rare to find a sunny day like this in Seattle. And those trees are actually just outside. We've got some beautiful blossoms. It's actually blossom outside the parking lot in our building. So we took this picture. Now that was before we shipped R2. So I don't know what our picture would look like after we ship R2, but so far it's looking good. All right. So during this TechEd conference, we've talked a lot about what we mean by the cloud OS. And as Jeffrey Snover and Jeff Woolsey pointed out, the cloud OS is not a product that we ship. It's not a DVD that you can stick into a machine and say, I'm installing the cloud OS. The cloud OS is a philosophy which allows you as customers to deploy our products in a variety of different scenarios and yet get consistency across all these three types of clouds that you can deploy. So today, a lot of customers are actually taking Windows Server, System Center, and now with the new announcement of Windows Azure Pack, and deploying it on-premise, right, in their own data centers because they have regulatory concerns or that's the way they've been doing it. And that is what we call as the customer premise in this segment, right? But there are also a lot of service providers who take these technologies and then deploy it in their own data centers. So their customers can actually log on to their environments and then utilize the capacity that the service provider offers to them. That is called the service provider in this picture. And then the third thing is we have Windows Azure, which is actually built with the same technology that we ship to you as customers. So we shipped Windows Server 2012 Hyper-V to you, and today in Windows Azure, we use this exact same version of Hyper-V in Windows Azure. So that allows you to gain the confidence to say that, look, the technology that we're shipping you is something that we ourselves are using at incredible cloud scale, right? And by actually having the same underpinnings of the cloud in Windows Azure and the all two other clouds that we have, you as customers have the flexibility and choice, an option to take any of your capabilities that you deploy on-premise and move them between any of these three clouds, right? So you have all the choice that you have because we use the same underlying building blocks across these three different clouds. Now, I don't mean to imply that we use System Center to manage Windows Azure, right? Because Windows Azure has its own has a different model of how they actually manage inside the data center. But the concepts that we use to manage Windows Azure are the same concepts that we ship to you as a part of System Center. So you as customers can actually take the underlying infrastructure of a Windows Server and then manage it to your scale. Okay? So in this session today, I won't be talking about Windows Azure, but I'll focus on the capabilities that we are shipping as a part of System Center 2012 R2 Virtual Machine Manager, which allow you to set up your own clouds in your own premise, or it allows a service provider to set up their own infrastructure so some other customer of theirs can utilize the capacity. So we'll focus on these two areas today in this conversation. So the cloud as a term has been, overhyped and overused in many, many different contexts. So with this slide, what I'm trying to, explain to you is what are the high-level concepts of a cloud. And a cloud at its very tenet, right? When you say cloud, your customers you as IT pros, your customers, when you tell them the word cloud, their mind goes to something like Windows Azure or Amazon. That's the cloud for them, right? And what the cloud really means is that there is a pool of compute, networking, and storage, which is managed by some mythical management entity, completely abstracted away from the consumer who's utilizing that cloud. That consumer can log on to a web-based portal. Using that web-based portal, they can spin up virtual machines, connect them to networks, and automation under the covers takes care of everything else. There is no man in the middle who's actually creating the virtual machine for them. It's all completely automated and self-service. And at the end of the month, you get a bill, just like you get a bill from the electric company, which says, well, you utilize this much of compute capacity, and therefore this is the bill for your compute capacity. That is what the cloud is, right? It's nothing very complicated. It's about enabling self-service on a charge-as-you-use basis on a completely automated infrastructure. That is what the cloud is. And what this session is going to focus on is how System Center, in particular Virtual Machine Manager, provides the foundation or the underpinnings for that cloud for the Microsoft solution that we give to you, right? So let's move on to say, what does actually a cloud constitute of? I talked at a very high level in the previous slide about what are the basic philosophies of a cloud. This one goes a little deeper to say, you've got a bunch of compute, networking, and storage, right? You aggregate them together, and you layer a hypervisor on top of it. Now, I want to be really clear in saying that, look, a cloud doesn't necessarily mean virtualization Although in most clouds, people tend to use virtualization because it gives you far better utilization and flexibility at the fabric layer, which is very helpful for the provider who's setting up the cloud, right? So you take these disarticulate pieces of compute, networking, and storage, and you aggregate them and pool them in a resource based on the service level that these offer. So you take your best compute, you take your best networks, and you take the best storage, possibly sitting on SSD drives, aggregate them together, and pool them together, and that's what you call as a resource pool. Now in VMM, we actually allow you to deploy compute, networking, and storage. And I'll talk about the changes that we have made in R2 to allow you to go deeper into provisioning these three types of raw capabilities and resources that you utilize inside your data center. Now that you've pooled these, in VMM, we introduced in System Center 2012 a construct called the cloud. And the cloud basically takes this pool of compute, networking, and storage and makes it and logically constructs it in such a way that that resource pool can then be sub-allocated to users of that pool, right? So, and that is what we mean by delegated capacity, right? Now, in a number of cases, we've come across where we actually name the cloud after the persona who's actually getting the cloud. So I've seen a number of demos where they'll show a marketing cloud and a finance cloud. That is actually not the philosophy behind how we developed it. The cloud is the core construct which gives you multi-tenancy. So you take the service level construct, mold the cloud based on the service level. So you should ideally have a gold cloud, a silver cloud, and a bronze cloud, each of which indicates a different service level that consumers of that cloud will get, right? And that's shared infrastructure. And then on top of the shared infrastructure, you create user roles and allocate capacity from these clouds. So for example, you could take a marketing user role, and in the marketing user role, you can say that, look, they can create 20 virtual machines on the gold cloud and 50 virtual machines on the silver cloud, right? And so the user role construct is what really gives you access to the capacity that you have on the shared multi-tenanted infrastructure called the cloud, right? These two pivots of cloud and user role are what constitute the core multi-tenancy aspects of Virtual Machine Manager, on which rests the entire multi-tenanted Microsoft cloud stack that we ship to you as service providers or to you as enterprise customers. Now that you've actually delegated the capacity, you want to actually do something with this capacity. And the way you do that is you model your applications in something called all right, now the chopper is gone, in something called standardized services, right? The idea really here is that for you as customers, you want an error-free way and a repeatable way of deploying your applications over and over again. And we have learned that, after running large data centers like Windows, Azure, Bing, and others, that automation is key to ensure that you have consistency inside your data center, right? And the way to automate is to actually create a service template of your application, make sure you get it right, iterate over it a few times, but once you capture the model of your application, thereafter stamping instances of that application should just be a matter of providing instance parameters and then letting this underlying automation take care of actually deploying all the services inside your environment. That is what is encapsulated in service templates in Virtual Machine Manager. Now that you've got all the plumbing in place, you need to expose this capability through a self-service portal so customers can actually log into the self-service portal, use the self-service portal, and then deploy these services or virtual machines in their environments. Right? Now, Virtual Machine Manager in of itself does not contain a self-service portal. We have all the plumbing, the role-based access control, the multi-tenanted shared infrastructure, the deployment of the fabric, the concept of the service template, which enable a self-service portal on top we built. And in System Center, the way that self-service portal is built is that you can actually use App Controller, which can talk directly to VMM and act as a self-service portal for you. Or you also have the option of using an HTML5 based portal, which is called Windows Azure Pack. And you actually saw it demonstrated in the keynote, and I showed it again yesterday in my overview session in System Center 2012 R2. And in many, many sessions, you can actually go learn about Windows Azure Pack. Now that portal actually requires a REST-based API to talk to. That REST-based API in System Center is provided by a component called Service Provider Foundation. So you got Hyper-V, actually underneath you got physical servers. On top of that, you got Hyper-V, which virtualizes the servers. Then you got VMM, which basically allows you to deploy the servers, configure the network, configure the storage, create the core constructs of multi-tenancy. And then on top of that, you layer a REST OData interface called Service Provider Foundation, and then you build a portal on top. And with this stack, you now have a cloud stack, which enables your customers to work in a self-service, self-operated manner, deploy virtual machines, and then operate those virtual machines. In this session, what we'll do is we'll focus on the fabric aspect of what VMM allows you to do. Now, before I go any forward, I'd be remiss in not mentioning the work that we're doing with partners. So we've been working a lot with Cisco, and in the end of May, Cisco announced the availability of the Cisco 1000V for Hyper-V, which works with Windows Server 2012 and System Center 2012 SP1. And the interesting thing is that the Cisco switch 1KV for Hyper-V is actually a free download, and it is free to use, which is a very, very amazing thing, given that we know how many customers already use Cisco. There is an advanced version which adds capabilities like firewall and so on and so forth, but the basic version of the 1KV, which allows regular switching, allows the Cisco 1KV to be managed by Cisco tools, is a free download, free to use, with no restrictions in terms of number of hosts or number of networks or anything of that sort. So we're really pleased with the work that Cisco has worked with us to actually make this happen. So that's Cisco. The other thing I wanted to show you was this screenshot. And what this screenshot is, so we work very heavily with the Storage Networking Industry Association to use SMIS as a protocol to manage storage area networks. And we go to this plug fest, which allows us to interoperate with these various SANs. This picture shows you, I think, over 15 or 16 SANs being managed by VMM. And they are from very many different vendors. We've got a list that we publish up in TechNet. And we know many customers, many here in Europe, who actually really, really appreciate the ability for them to be able to manage their storage from inside VMM. Right? So I just wanted to share with you the work that we've been doing with the industry to enable storage management from inside VMM. Now, in terms of the investments that we made in VMM, they were pretty much across the board. But just to give you a little bit of context, we released 2012 SP1 in January of this year. And we are releasing an R2, we've released an R2 yesterday, the preview release of R2, which comes about 5 months after we released the SP1 release. So obviously there is not a whole lot of time that we've had. So the investments in 2012 R2 are not at the scale and scope of that came in 2012 SP1. But they are pretty substantial in of itself. And these are the 6 areas across which we actually invested in System Center 2012 R2. Now, when preparing for this session, we ran into a dilemma. And here is the dilemma. In all the sessions that have preceded this session, almost every demo that I wanted to do or talk about has already been shown by now. It was shown in Jeffrey Snover's session, in Jeff Woolsey's session, then it was shown by Ben Armstrong. So all the sessions on networking, Hyper-V, have almost shown everything that I wanted to show you about what's going on in VMM. So what we said was, instead of actually giving you a list of things that VMM allows you to do, what I've tried to structure this talk is from 2 perspectives. I'm going to give you a perspective of an admin who's sitting inside the enterprise and wants to create their environment inside the enterprise. And there is another admin who's sitting in a service provider's premise, and they're going to configure how the service provider sets it up. Right? And so what we're going to do is, here are the 2 people I want to introduce you to. There is a company called Wingtip Toys. It's a toy company which makes amazing toys. And there is a lady by the name of Erin, who is the infrastructure admin on the enterprise side. And then there is a unnamed person who works for a company called Contoso Hosting. And Contoso Hosting, or rather it should be Fabricam, is a company that allows is a service provider which takes System Center, Windows Server, and Windows Azure Pack and offers IaaS to their customers. Okay? And so what we'll do in this conversation is we'll talk about how each of these administrators can use VMM to satisfy their needs. And what I've tried to do throughout the talk is use these two colors to indicate where that particular content or material is relevant. So if it's relevant to both, you'll see both those boxes. If it's relevant mostly to the service provider, you'll see only the green box indicating that this content is most relevant to a service provider. I do want to point out that from a system center perspective, from a Windows Server perspective, we don't ship anything special to service providers and special to enterprises. It is the same software that we ship to everybody, but there are certain capabilities which are more relevant to service providers and certain which are more relevant to enterprise customers. But we have made no distinction between what to ship to each of these markets. All right, as all great enterprise IT people know, or anybody in the IT space knows, the first place you start your project is on a whiteboard. So let's take a look at what Erin's whiteboard looks like. So what she wants to do is she wants to basically configure and deploy her infrastructure. So if you go back to the basic tenets of the cloud, the first thing you need to do is to configure and deploy your infrastructure. So she is going to use some fiber channel SAN. She's going to use scale-out file server with Windows Server 2012 R2 with JBODs, and therefore using storage spaces, right? And then she wants to cluster those Hyper-V hosts. That's what she would do. Now after that, then she needs to go set out her networking, where she will actually model her physical network using a construct in VMM called logical networks, right? And she will create switches called logical switches, which allow you to manage the individual instance of a Hyper-V switch on each Hyper-V host as an aggregate of all of them, right? And then she will create virtual networks, which is what virtual machines connect to. So if you come down from the virtual machine perspective, a virtual machine connects to a virtual network. A virtual network underneath it needs to be bound to a logical network, right? And that's how the packet goes out of the system. VM connects to VM network, which layers on top of a logical network, right? And now that she's done this, then she'll create a cloud out of the resource that she's set up, and then she'll delegate capacity for these clouds, from these clouds to the various departments that exist in this enterprise company, right? But now let's see what happens. What happens if Wingtip needs to run a massive marketing campaign for which they don't have the capacity inside their own data center? So in those cases, they're going to reach out to capacity of a service provider. And Erin is preparing herself to make sure that if she runs out of capacity, she's going to consume the capacity from a service provider. But when she's consuming the capacity from a service provider, she wants to make sure that the capacity that she gets from the service provider can be consumed by her and by her customers in a manner that extends the network out into the service provider's environment and makes it appear like a local network to her. So VMs and others can actually join domain controllers and can access resource inside the enterprise just as they were running locally. All right? Now, in terms of understanding how to deploy systems, when we deploy large systems like Azure and Bing and others, one of the key learnings that we have learned is that consistency is key. And what I mean by consistency is that, try and be homogeneous in the kind of hardware that you acquire. You'll run into far less problems when you have homogeneous hardware because you would have flushed out all the challenges that that particular stack has for you. And when you actually deploy, you should deploy in the construct of a stamp, right? And it's a unit of compute, networking, and storage, which is generally managed by System Center, right? And a single data center, depending on the amount of capacity that you want to expose, can have multiple stamps, right? So generally when I say stamp, it refers to the scale capacity of a single instance of System Center, right? So let's say if you want to have a massive scale of 100,000 VMs, right? In which case you know that VMM has a restriction of being able to support up to 25,000 VMs per instance of VMM server, which means that you're going to require 4 stamps and you'll put up 4 instances of VMM, each one of them managing a capacity of 25,000 VMs, right? Now this is where I say we take the learnings that we take from running these large clouds and actually bring them to you. Because if you go look at Windows Azure is built exactly the same way. We have an instance of a fabric controller which manages a capacity of up to 880 hosts. And then this is called a stamp, and then we have multiple such stamps spread out globally. and they are aggregated by an API layer called Red Dog Frontend or RDFE, and then layered on top of that is the Azure portal, right? That's how we actually build our systems. Now that you've actually got stamps, you want to make sure that the VMs that you deploy on these stamps actually have disaster recovery enabled for them. Okay? So let's go take a look at a little more, what does a stamp really look like? So here is a rack, which has got storage, which has got some compute, and it's got some edge components. And when I say edge components, these are the machines which are going to provide ingress and egress from a networking perspective into your components that are deployed on this rack, right? And on the top of that, you notice I've set aside a certain capacity for deploying the management infrastructure. So that is the infrastructure of Hyper-V hosts, where you will actually deploy VMM, operations manager, data protection manager, service manager, configuration manager, anything that you require from a management perspective, right? Now people come up and ask and say, well, should I virtualize my management infrastructure or do I need to keep it physical? And we are saying, we are recommending, virtualize every workload, and that includes systems management. So if you want to deploy system management, system center, VMM, OM, deploy them as virtual machines. It'll give you a far more flexible infrastructure and allow you to scale it out and manage it in a much better manner. Now previously, we had certain limitations in VMM which would prevent VMM running as a VM from managing a cluster on which that VM was sitting. That limitation has been removed. So you should be able to use VMM to manage a Hyper-V host cluster on which the VMM server itself is sitting as a virtual machine. And when I say virtualize every workload, virtualize even the SQL instance that is backing Virtual Machine Manager. And in fact, right now inside our labs in Redmond, we are actually testing this out at scale, where we've got a shared SQL farm, which is serving out as a database for VMM, OM, and others. And everything is virtualized. So now that you've got this, let's take a look at what that management component looked like. Like I said, it's going to have everything as a VM, Service Provider Foundation, Operations Manager, VMM, and others. On the edge component is where you run the virtualization gateway and the top-of-rack switch, right? So I'll talk a little bit about what we do with the top-of-rack switch a little later. But the virtualization gateway is what allows you to break out of the bubble from Hyper-V network virtualization. And I'll talk about the investments that we have done in this release to make that happen. On the compute side, cluster all your Hyper-V hosts, right? So all your hosts should be in a highly available cluster so that your VMs that get deployed are automatically in a highly available configuration. Like I said, consistency is important. So even though you may have the need for some VMs not to be highly available, by actually building it in a consistent manner, it reduces your complexity. You don't have to deal with some hosts which are not clustered and some which are clustered. Although we support that, we absolutely support it. But we recommend that be consistent so it's easier for you to deploy and manage. And then from a storage perspective, VMM, like I showed you, we support third-party storage like SANs. You can build it out using file servers. It really doesn't matter. We support file servers backed by Spaces, file servers backed by SANs, or directly SANs using iSCSI or synthetic fiber channel, right? And then you can have multiple such racks. And at some point of having these multiple racks, you'll run across the scale limitations of a system center component. And when you reach that limitation, that should be your definition of a stamp. And I can't tell you what the definition of a stamp exactly looks like, because in each of your data centers, you have a different requirement and a different need. All I'm saying is, in your environment, define what a stamp means for you, and then stamp them out over and over again. That's how you get consistency and automation. All right, and why is this important? Well, the first and foremost thing is when you're deploying a stamp, if you go back to this picture, if you go back to the first picture, you notice that the management head exists only on the first rack, right? So before deploying the management head, you actually need to deploy storage for that particular rack. For rack 1, you need to actually deploy storage, deploy a Hyper-V host cluster on which you can deploy the management components. Deploy storage, deploy the Hyper-V host cluster out of band, install VMM as a virtual machine on that management cluster, and thereafter, if you do any other deployment of compute, networking, or storage, do that through VMM. Okay? And that's what I mean by this. Create a single storage and manage infrastructure first. Use VMM and service templates to deploy other management scale units, and then configure the rest of the system. Now, as a part of the 2012 R2 release, we have templatized all of System Center. Now, at the preview release, we are not releasing those service templates, but over the course of the release, and maybe a little after the actual RTM, we will release service templates for all System Center components, VMM included. So we will self-templatize ourselves if you want to deploy another instance of VMM. So you can templatize, we've templatized OM, DPM, SM, all of them. And you can actually take those service templates and deploy them in virtual machines through VMM. All right. So let's give you a sense of what does network overview look like. Now, this picture that I've drawn is more akin to what you're likely to find inside a service provider. So the first and foremost is you've got a public internet-facing network, right? And you'll have a corporate network, which is internal, right? Which allows you to access internal resources. And you'll have some kind of a bridge or a firewall which isolates these two networks together. You'll need a management network which allows things like VMM to go talk to the Hyper-V hosts, because we need to bare metal provision them. So you need to go onto a baseboard management controller and go on to deploy things like that from via the management network, right? And then you need another network for your live migration traffic, your cluster traffic, and your storage traffic that comes out of your Hyper-V hosts. And for the tenant virtual machines, we are recommending that you virtualize your network using HNV, right? So you have a physical network for the tenant VMs, but for each of the tenants, you actually create Hyper-V network virtualization or VM networks, which are backed by Hyper-V network virtualization. And we, out of the box, will ship a gateway which will allow those VMs or those tenant VMs to connect out from those virtual networks out to the internet. Okay? And then Windows Azure Pack actually needs an internet-facing component, because as a service provider, you need your portal on the web, and then you need access to the backend management network, because that is how Windows Azure Pack will talk to VMM and SPF, so that those components can actually do the right backend work to automate all the things that are required. All right? Isolation is key. Make sure you isolate all your networks. And for tenant isolation, use HNV. That's our recommendation. Now let's look at what a storage architecture needs to look like, right? So like I said, from the perspective of VMM, we can support many, many different storage architectures. On the left-hand side, you see we've got a SAN, and you can have block-based access to storage using iSCSI or fiber channel, right? And that exists both for the guest as well as for the Hyper-V host. We also support third-party NAS devices who support the SMB 3.0 protocol. And then, if you want to use the Windows Server file server, you can layer that on top of storage spaces and connect just a bunch of disks, or JBORDs, as they are called, to create a storage system, right? So the Hyper-V VMs can be stored on a block device or on a file-based device. And VMM will allow you to manage all of those. All right. So now let's go and actually do a few demos to see how do we actually build out this infrastructure, all right? So let's talk about the management components. When you deploy the VMM server, you need some storage for the compute nodes, and we're going to show you how to do that. And then we're going to show you how you can take VMs that are running who you want to cluster in the guest. I told you virtualize every workload. Okay, well, if you're running SQL, you want to actually cluster SQL servers running as guests, right? For a cluster, you need access to some shared storage. Now, you can access that shared storage using a file server, or if you want to do it using a block-based device, then you can access it using fiber channel. Now, prior to System Center 2012 R2, we did not support the use of fiber channel inside the guest. You could expose it through Hyper-V Manager, but VMM did not manage it. In this release, we've added support for you to actually take fiber channel all the way into the guest, and we not only do that, but we also program the physical fabric switches for storage to zone them appropriately so that the LUNs can be exposed directly into the VMs, right? The next thing we talk about is, okay, if you want to create a guest cluster, well, you can access your storage on a file server, you can put it on iSCSI, put it on fiber channel. But we've introduced a new capability which allows you to create guest clusters by just using a VHDX file which is sitting on some shared medium. So you can create a file server, plonk a VHDX file on that. And then you can create VMs which can actually share that VHDX file using Windows Server 2012 R2 and System Center 2012 R2, and then you can create a guest cluster using that shared VHDX infrastructure. No use of iSCSI, no use of fiber channel. Just natively out of the box, you can actually create guest clusters without any other infrastructure. All right. So here is the demo that we are going to go through, right? So I'll talk about how we can actually deploy your storage. And the demo I'm going to show you is we got a bunch of disks that have been pooled together to actually create a storage space. We layer a file server on top of that, and we'll show you how VMM can actually provision storage. All right? So let's go take a look at that demo. Oh. All right. So this is VMM, right? The first thing I want you to notice here is this. So we've added a new node, which is called physical computer profile. So prior to 2012 R2 release, VMM could only provision physical machines and turn them into Hyper-V hosts. With the release of 2012 R2 Virtual Machine Manager, you have the choice of actually creating a Hyper-V host or a file server. So if you can actually create a physical computer profile. And when you actually create the physical computer profile, I want you to take a look at this option. We give you the option of either turning that profile so that the host that gets deployed with this profile will be created as a virtual machine host, or it will be created as a Windows file server host. And I want to digress a little bit about why we are so invested in something like profiles. Our philosophy is that anything that you want to deploy inside the data center should be modeled. So if you're deploying virtual machine hosts, you should model them using a profile and then stamp them out over and over again so they're consistent. Similarly for file server profiles. So you have a profile which captures how you want your file server to be configured and then just stamp that out over and again. Now over time, we want to do that even for things like networks. So you allow you to model your networks and then you can go stamp them out over and over again. We are not there right now, but that's the philosophy behind using templates and profiles. And that's where we want to get to over time. All right? Now, I'm not going to actually go through the act of creating a profile at this point of time. Suffices to say that I've got a file server profile that's been created. Okay? And this tells you how the file server needs to be constructed using JBoards and so on and so forth. Now, what you can do is you can go to the fabric and you can actually create a file server cluster. Right? So you can give it a name. You can give the file server a name as well. I'm sorry. I make that mistake always. All right. Now the thing here I want you to recognize is that the file server profile that we had previously constructed, which models how your file server to be laid out, is what you select here. You select a run as account, which will allow you to talk to the baseboard management controller. Right? And thereafter, you can actually go and add the nodes in the cluster, okay? And then run through a discovery process, okay? I want to provision bare metal machines, I'm sorry. Now at this stage, you need to actually be able to talk to the baseboard management controller. So you'll need an account to do that as well. And to talk to the baseboard management controller, this is the same screen that you would hit when you're trying to deploy a virtual machine host. Now I'm not going to go any further from here, but it suffices to say that from this point onwards, you can use this to actually go deploy your Windows file server. And we'll automate the entire infrastructure from this point onwards. Okay? Now this takes a little bit of time. So I've already done that. And we've got a Windows file server that's already been deployed. Okay? And we've got a bunch of SANs in this environment as well. So I won't go into that part, the deployment part, since we've already done that. Let's go take a look at the library right now and see what we have. Let's go back to the VMs and services and let's see what we have there. So we've got here a file server cluster that's already been constructed. So that's how you actually go deploy your file servers. Okay? Now let's bubble up and let's talk about what you can do inside the guest. Okay? Now inside the guest, let's go take a look at the properties of this particular this virtual machine. Let's go take a look at the storage, right? and see what you can do here. Now, this is the work that we have done, which allows you as customers to be able to use synthetic fiber channel inside the guest. So we not only take the LUN and allow you to create the LUN on the SAN, but like I said, you also can create the zone here. And by creating a zone and using the WWPNs, you will actually go configure the fabric switches, Brocade or Cisco, right? And we'll configure them so that the SAN and the LUNs from the SAN are exposed all the way into the guest virtual machine. Okay? So I'll leave that for now and move on. All right, so this is what I showed you, which allows you to deploy your storage infrastructure where you got storage spaces and SMB 3.0. And I think I've already finished this demo. I should have waited for the slide. But effectively, the model here is that you got a synthetic fiber channel exposed into the guest. You got a SAN, which is exposing those LUNs. And using the screen that I just previously showed you, you can expose that LUN and configure the fabric to expose that LUN into the virtual machine. All right. So we've done this. Let's move on. So how do you actually reduce the time it takes to deploy virtual machines? So when VMM deploys, we have our artifacts sitting in the VMM library, which is a file server. And then from there, we have to copy it to the Hyper-V host. Now, in order to copy it to the Hyper-V host, so far, we have relied on a protocol called BITS. Now, BITS is good, but it's relatively slow. And today, you have offloading data capabilities, which allows you to make use of the capabilities that exist on the SAN. Right? Now, Hyper-V added support for ODX in 2012, and in this release, we allow you to actually deploy virtual machines using ODX if there is a shared SAN infrastructure between the VMM library and the Hyper-V host. Now, just to give you a sense of how that works, let's go take a look at a demo. So here, I'm in the VMM server, and these are two screens which will show you the network traffic that exists between the Hyper-V host and the VMM library. And I'll start by first deploying using bits. Now, this will not complete, because in order for me to complete this, it'll take a significant amount of time. But pretty soon, you should actually see that there should be a spike in the network traffic on the Hyper-V host and the VMM library. And this is the amount of data that we are transferring right now from the VMM library onto the Hyper-V host. And I normally let it go for about 30 seconds and then shut it off. And you'll see it roughly, it has completed about 7 to 8% of the entire data transfer is completed. And I won't let it complete. We'll kill it. So it did about 7%, right? And now what we are doing is we are actually transferring using ODX, right? And it's using a NetApp array. The thing I'd like you to notice is if you look at the network traffic, that has logically dropped to almost to zero, because there is no traffic going over the network now. It's all being copied in the back end using the NetApp SAN. Okay? And in the time that it took to complete 7% of the bits transfer, I'll actually go ahead and have a fully deployed virtual machine on that Hyper-V host. Okay? So I'll move on. All right. So the other thing I wanted to show you was, what do you do about creating guest clusters using shared VHDX? So the way you do this is that you can actually have shared infrastructure without having to use block protocols like iSCSI or SANs to actually expose LUNs into the VM and then create a guest cluster. So the demo I'm going to show you right now is how a customer can actually create a SQL guest cluster using shared VHDX. Okay? And just like we are going to release all the service templates for System Center, we are also going to release this service template for you so that you can customize it and use it to deploy your SQL guest clusters. All right? So let's go take a look at this demo. All right. So the first thing, let's go open up the service template for this guest cluster. So this is the service designer. It is showing you a simple service template which allows you to cluster SQL as running as a virtual machine. Okay? Now let's go take a look at the properties of this. Now if you go back, how does a cluster get created? For to be able to create an SQL cluster, you will do the following. You will install a virtual machine. You will add the Windows Server clustering role to that and create a cluster. Then you will add a second node, and you will add it to the cluster. Then you will deploy SQL on the first node, right? Cluster it, and then each of the subsequent nodes you will deploy SQL and then add SQL to the failover cluster of SQL, right? So there are two layers of automation that you need to work with. First is create a VM, create the actual Windows Server failover cluster, and the second layer is to cluster the SQL server itself. Now, we allowed you to automate what you can do inside service templates using scripting. But in order to, if you look at this model, you'll see that the first node in this system actually does something special as compared to what the other nodes do. So in 2012 R2, we've allowed you the capability to do things for the first node differently from what the other virtual machines will do. This is what allows you to actually be able to create guest clusters, because the first node does something special and the second node does something different. If you go look here, in this what I'm doing is I'm actually calling a script called first.cmd, which is creating a cluster. And this is a runtime name that you will give for the actual creation of the cluster. Okay? So if you go here, I won't go through the entire script, but this is the PowerShell script which is actually creating the cluster. This will be run by the first virtual machine that spins up. Now the second virtual machine that spins up will run this script. And if you look at this script, in this script all I'm doing is I'm adding this node to the cluster. I'm not creating the cluster, I'm adding this node to the cluster. Now the same thing also exists for the SQL scripts. The first script will actually just install SQL, right? This will just install SQL, and the second script will actually cluster the SQL instance. Will cluster the SQL instance. If you look here, it is basically just doing an add node functionality. It'll add the SQL server to the existing SQL cluster. Okay? So with this, you can actually create guest clusters and automate the creation of those guest clusters. All right. And you can do this using shared VHDX. In the VMM console, when you create the service template, actually, let me just show you that for a minute. Let's go back to the designer. And if you look at the properties of the hardware and look at storage, you'll notice here that these disks actually have this capability which says share the disk across service tiers. So all the multiple instances that spin up as a part of the service template will actually use the shared disk as a block-based access to be able to create a guest cluster. This is what allows you to create guest clusters using shared VHDX. Okay? All right. So we looked at the network. I think I talked about this entire network. Now let's go and see how we can actually realize parts of this network. The first and foremost thing we recognize when we talk to customers is that, a lot of times the physical network is supposed to be configured in a particular way, which is captured in VMM using logical networks. But today, the way you construct logical networks is you go to the VMM console, you enter the information that is provided to you by a network admin, which says, here is a network, here is a subnet, and here are the VLANs that correspond to this particular logical network that you want to create. But you have no way to be able to going back to the actual physical network infrastructure and querying it to say, is the physical network even programmed correctly? And that changes with 2012 R2. So we've introduced a new layer called the data center abstraction layer, and using a standard protocol called OMI, we can configure or we can actually communicate to the physical network infrastructure. And Arista has already announced the ability to ship OMI on all their switches. And we are working with the other networking partners to make sure that they do that as well. So the demo that I'm going to show you right now is how I can actually measure the compliance of the logical network that is defined right from inside VMM. All right? So let's go to here. And if you look here, this is a physical host which expects the physical switch or the physical port that is configured to connect into this Hyper-V host needs to be in trunk mode, right? whereas it has been set into access mode. And the reason we can get that is because we can actually talk to the physical switch and find out what has that port on the Arista switch been configured to. But now that you recognize that this is a problem, you can actually go through an act of remediating it. So I have a button here which says remediate. Because remember, you've captured your logical network in VMM. So we know what that network needs to look like. I just hit remediate. And what I've done effectively is, using the same protocol, I'll actually go talk to the switch and go and reconfigure the switch so that the switch can now set that port to trunk mode. Now let's go to see if the VM has actually started getting communication back. So far, you'll notice that it's still not reachable. This is a VM that's sitting on this Hyper-V host, and the reason this VM can't reach out is because the trunk port, or the port on the physical switch, has not been configured correctly. Now if all goes well, in a few seconds, it takes about 30-35 seconds, you should actually see that this VM will be able to communicate out because I've reconfigured the physical switch and done the right thing there. Let me go take a look at the job to see if it's... there you go. So if you see here, the host was unreachable. Using the remediate switch, remediate capability, I could go out and talk to the physical switch. Okay? So this is the new functionality that we've added as a part of this release. All right. Now the next thing to look at is hybrid networking. So what is hybrid networking? I talked about the fact that Erin, sitting in Wingtip Toys, needs to access capacity from her service provider. And the way she's going to do it is that the service provider is going to give her some access to some capacity, and she's going to use that capacity to actually create virtual machines on that capacity and then wire them up back into her environment using the networking edge gateway. All right? Now, in the 2012 release, Windows Server 2012, we did not ship a multi-tenanted gateway. And you as customers needed to rely on third-party gateways which would allow you to virtualize the connectivity between the virtual network and the physical network. In 2012 R2, we're actually releasing an inbox capability which can act like the gateway. And it is encapsulated in a role, the Windows RAS role, allows you to act like a Hyper-V network virtualization gateway. Not only can it act like an HNV gateway, it's multi-tenanted. It also can act like a VPN edge device, okay? And it'll act like a NAT device as well. All right? So let's go and see how we can enable this and give you a demo of how we can construct this. Now, I am a customer of, I'm Erin, right? What I want to do is I want to log on to my service provider, who's Fabricam, and I'm going to create a virtual network in Fabricam and then wire up that virtual network to my site. So let's see how you're going to make that happen. This is the Windows Azure pack. And for those of you who looked at the Windows Azure portal, this is consistent. But this is powered by System Center under the covers. Now I can go here and actually create a network. And I just create new. I'll do a custom create. And I'm going to create a virtual network. Let's call it okay. I'm going to create a V4 virtual network. You can create a V6 as well. And a number of times people ask me, why don't you give V6 demos? I'd be happy to do it, but it's really, really long to type out those V6 addresses. That's the only reason. Now you need DNS servers. This DNS server is what's going to resolve the IP addresses on this network, right? I'm going to give it a name. Now this is where you can say whether you want this network that you're creating in the service provider to be able to connect back into your enterprise. And I'm going to do that by saying I want to set up a site-to-site VPN there for me. I'm going to select it. Now the moment I select it, I need to tell it what gateway subnet I'm going to use. But here is another interesting thing. We also enable you to use iBGP on this link. And what that enables you to do is that if you've got inside your data center new network spin up, BGP will automatically configure both ends to make sure that the routing infrastructure on both ends can route the traffic between these two sites together. Okay? I'm going to just leave that unchecked for now and then move on. Now this is what allows Erin as an administrator to say, how much of a subnet do I need? She can provide her own IP addresses. She can use any other IP addresses, and so on and so forth. I'm just going to leave it as it is. And now I need to provide a VPN connection as well. So I need to give her the connection parameters. Now remember, I am giving this information to the service provider. The service provider needs the IP address of the edge device on the enterprise, because her VPN infrastructure, which is the RAS gateway, will dial out into this box. I'm going to give it the IP address, and I'm going to give it a shared key. I'll leave the the address space alone for now, and then just move on. And now what we have done here is that within a few clicks of the button, Erin has basically gone to the service provider, and the network for her is being constructed under the covers using VMM, which is now actually configuring the RAS server with all this information that was provided, and then it will use that to dial back into her environment. And in fact, in this, you don't actually see this, but at the end of the day, Erin will also get a script which she'll need to run on her devices. And her device can be a Cisco device, a Juniper device, and she'll run that script on that device so that that thing can connect back correctly here. Now, I'm not going to wait for this to actually complete, but let's go take a look at the VMM server, which is backing that particular infrastructure. And let's go take a look at the VM networks. And if all things have gone well, you will actually see this new network that's been spun up called Europe Demo. So what happened was Erin logged in, did some stuff, that call came down to SPF, and VMM is now constructing that network for her. Right? Now that is not to say that you can't create your network yourself directly through VMM. What I'm showing you is the enablement of self-service for network creation. Okay? Let's move on. Okay, so we showed this network demo. The next thing, the question we've been asked very often is, what are you doing for enabling Hyper-V Replica and Virtual Machine Manager? Well, we have announced a capability called Windows Azure Hyper-V Recovery Manager. And this is a SaaS service that runs in Windows Azure. You take two of your sites, where you may have one VMM server on one site and VMM server on the second site, and you publish information about your clouds into this site. And then using this SaaS-based application, you can program how you want the failover to happen. And once using this SaaS-based application, you can actually make the failover happen in a test mode, or in a real unplanned mode. You can actually do the failover there as well. Now, the only data that actually goes to the cloud is only metadata. The actual virtual machine data is sitting on your data center premise and is flying across the wire to the secondary site on your own networks. That data does not go through Windows Azure, right? What is there in Windows Azure is only the ability for you to orchestrate how you can construct your recovery plans and say, in this case, I want this virtual machine to spin up and this virtual machine to spin up second. So what I'm going to do now is going to give you a very brief demo of Windows Azure Hyper-V Recovery Manager. All right. So let's go take a look at this portal. Now, this is Windows Azure. This is not Windows Azure Pack. This is real Windows Azure. And you'll see here, there is a new tab called Recovery Services. Now, you get this once you sign on to the ability to do recovery services. And once you sign on to the recovery services, you get a download that you need to install on your VMM server, right? After you construct that, you create a recovery vault. And then you can get, in my case, I have done it only using one VMM server, which is protecting two of my entities, right? And here, you can actually go author recovery plans. The authoring of the recovery plan, this is a simple recovery plan that I have, right? It's very, very basic. But this recovery plan allows you to construct how you want your virtual machines to be to shut down on the primary site and then start up on the secondary site, right? And so the entire orchestration is done for you in the cloud, okay? And the underlying replica engine allows you to actually make the replication happen. And now if you go to the VMM server, which actually has these VMs already running, let's take a look at these VMs. And the thing that I want you to focus on is these two buttons on the top, right? So these two buttons actually show up when you actually download and install that plugin from the cloud. You can enable recovery for a virtual machine or disable recovery for a virtual machine, either at the time of construction of the virtual machine or at any other subsequent point in its lifetime. Okay? So this is how we are enabling Hyper-V Replica to be utilized inside VMM. It's a SaaS service which does the orchestration, and VMM is the engine which actually communicates to the Hyper-V hosts and constructs or allows you to mark VMs for recovery, and from the cloud you can actually do the test recovery and the unplanned recovery as well. All right. All right. The next thing, we made a big change was in 2012 SP1, if you wanted to say that this particular user role had certain actions on a particular cloud and certain actions on a different cloud, there was no way to do that, right? And so what ended up happening as a result of that customers ended up having to create multiple clouds because they wanted to give me as a user certain permissions on this cloud and certain permissions on this cloud. Well, with 2012 R2, we've changed that. So you can actually take a user role and you can say that this user role has the following permissions on this cloud and the following permissions on this cloud. To all the clouds that that user has access to, you can individually define what are the permissions that that customer has. Okay? The next thing I want to talk about, and I touched a little bit on this even in my session yesterday, is that we made a lot of investment so that you as administrators have good monitoring information at your fingertips using our connector into Operations Manager, right? So we made a lot of investments in enhancing the VMM MP itself, and we've actually got some pretty nifty dashboarding capabilities as a part of this MP. And what I'm going to do now is just show you briefly a dashboard that has been constructed using these capabilities. So here I'm logged into an Operations Manager which has been hooked up into VMM, right? And as you can see, I can look at all the hosts, I can look at the storage pools, I can look at the file shares and LUNs, the network state. All these are available to you as a part of this new MP, right? And more importantly, we also have this ability for you to go look at the underlying physical infrastructure to see how that networking infrastructure is operating. You can actually go look at the network vicinity dashboard, and in this dashboard, you'll see that we actually go query the physical network infrastructure and show you how the switches are connected. You can actually pivot to show how the computers are connected into the switches, and this will show you, in this case, it is showing you that this link is having some trouble, right? Now, by no means are we saying that this is turning into it. By no means is this a network operations center console. This is not going to replace those tools. But at least you as administrators now have the visibility into what your network is doing, so you can have a meaningful dialogue with your networking administrator to say, hey, from my perspective, this network is down, here is the tool I'm using, and this is the problem I'm seeing on the network, right? Because a number of customer sites we've seen over and over again, where the customer is going back and forth with the network admin and saying, well, I don't think the network is working correctly, and the networking person is saying, well, I can see it working fine. Right? So this gives you the visibility and allows you to have a meaningful conversation with your networking administrators. All right. So in summary, what we have done is it builds upon the investments that we made in Windows Server 2012 and System Center 2012's SP1, right? And it enables a whole bunch of end-to-end scenarios which enable the philosophy of the cloud operating system. And for those of you who like lists, there's a list in the appendix section of this presentation which talks about the list of features that we've added as a part of R2. But the way we constructed this presentation was to help you understand how we would, suggest that you set up your environments. All right? So this brings me to the end of my talk, and I'd be happy to take questions at this point of time. Yes. Thank you. So the question was, what privileges are required by me on the switch for me to be able to change the port from access to trunk? Your networking administrator has to give you configuration privileges on that particular switch. And what privileges you get will vary from switch vendor to switch vendor, because their RBAC systems and capabilities are different, but you definitely need to be given that right to make that happen. And it's actually encapsulated inside. So the way you communicate to the switch is through the OMI provider. And when you register the switch, you'll need to provide the right kind of account, which we will use to authenticate ourselves when we go talk to the switch. So that account needs to be given permissions to go configure the switch. And what permissions you need will depend upon what RBAC system is in place for each switch vendor. Yep. Yes. So the question is the self-service portal going to come back? No. We already have 3 of them. The 4th one is not coming back. The VMM self-service portal is not coming back. If you want to use one right now, use App Controller, which gives you high fidelity with service templates and everything else in VMM. However, if you're just using VMs and don't want to use service templates and are more interested in HTML5 based portal, then use the Windows Azure Pack portal. The question is, what is the upgrade path from SP1 to R2? None. We're just going to leave you on the street. No, I'm kidding. We actually have a full upgrade path. It's fully supported. When we release, you'll be able to upgrade from SP1 to R2. But as again, whenever you're doing an upgrade, make sure you back up your database before you do anything else. Back up your database and then do the upgrade. But we will support an upgrade, absolutely. Now, I can tell you that the upgrade from 2012 to SP1 was not that simple, because in SP1, you required the VMM server to be deployed on Windows Server 2012. In R2, there is no such requirement. The VMM server in 2012 R2 can be deployed both on Windows Server 2012 and on Windows Server 2012 R2. So the upgrade path is much simpler than you had from 2012, from SP1 to, from 2012 to SP1. Yes?
How do we back up a shared VHDX?
So the question is, how do we back up a shared VHDX? So the question is, will DPM know if it can back up shared VHDX? My belief is yes, but I'm not sure. I'll be happy to give you a card of mine, and there are some people here from the DPM team as well, so I don't want to give you a wrong answer, but I believe they do. But let's make sure that I get you the right answer for that, right? Yes. Yes.
Use Hyper-V replica with shared views.
The question is, can you use Hyper-V replica with shared VHDX? No. Next question. So let me rephrase the question, if I may. So you're saying, you're asking, does SPF expose more information than just VMM for performance monitoring? Is that the question? At this point of time, no. Actually, I stand corrected. There is a little bit of information that we do expose, because if you actually go to the Windows Azure Pack, we do show you some performance metrics of the VM. And they are coming through VMM, and so SPF does have that API call to get that. Yes. Next question. All right, thank you so much. Yes, have a great conference. Sorry.